The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This video will provide an introduction to the standards of mathematical practice in the Common Core State Standards for teachers who work with students with significant cognitive disabilities. This training, an overview of the Common Core State Standards for mathematical practice for use with the Common Core State Standards, is one in a series of training videos that will support teachers of students with significant cognitive disabilities in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. These are the 8 standards of mathematical practice, guiding the Common Core State Standards in mathematics. As you read over these, keep in mind that these are proficiencies and processes that have had long-standing importance in the world of mathematics education. They were derived from the National Council of Teachers of Mathematics and the National Research Council's report, Adding It Up. These are the standards that students at all grade levels should be working towards as they learn mathematics and the specific Common Core State Standards in mathematics. These are also the standards to which the essential elements are linked. This is a grouping of the standards of mathematics developed by McCallum in 2011. As you can see, some of these standards naturally fit together. As we review these standards in depth, we will start to unpack the ideas that surround each standard while giving classroom application to how these standards come together to help us build strong, research-based instruction for students with significant cognitive disabilities in your classroom. Standard 1. Making sense of problems and persevering in solving them. This standard states that mathematically proficient students start by explaining to themselves the meaning of a problem and then look for entry points to its solution. They analyze givens, constraints, and relationships, as well as goals. They make judgments and guesses about the form and meaning of the solution and plan a solution pathway rather than simply jumping into a solution attempt. They monitor and evaluate their progress and change course if needed. They are able to recognize correspondences between equations, describe tables and graphs, or create diagrams of important features and relationships. By graphing data, they search for regularity or trends. They also check their answers for problems using a different method, and they continually ask themselves, does this make sense? Let's take a moment and clarify some of the math language by looking at the following problem. There were 7 children at the party. Some more showed up. Then there were 15 children at the party. How many more children came? This problem has givens, constraints, and a goal. Think of the givens as the information that is stated or given to us to use to solve the problem. The givens in this problem are there were 7 children at the party, some more showed up, then there were 15 children at the party. Think of the constraints as the limitations or restrictions within the problem. The constraints for this problem would be, I know that the number of children who came must be more than 7 and less than 15. This problem also has a goal. Think of the goal as the information that we are looking for in a given problem. The basic goal of our problem would be to find how many more children came. Classroom applications of Standard 1 include teachers having students work in groups or pairs in which they have to explain to each other the methods they are using to solve the problem. Teachers may also provide students with multiple methods to solve a problem, and then allow students to choose which method makes the most sense and allows them to come to an answer. What might this standard look like in a classroom for students with significant cognitive disabilities? For this population, we often try to give them numerous mnemonic supports and ideas to help them make sense of the mathematics they are dealing with. Take, for example, keywords. We imply that keywords often tell us which operation to perform, whether it is addition, subtraction, multiplication, or division. The bottom line is that keywords don't really work and actually result in the suspension of sense-making. As we get into further training, we'll see why these keywords often are misleading. One example of this misuse of keywords occurs when we tell students that more means you should add. Then we see a word problem, such as Erin has 46 comic books. She has 18 more comic books than Jason. Using the keyword approach, the word more would imply add, and if students perform this operation, they have 46 plus 18, which gives them 64. But 64 is not the answer here. Choosing to add because the word more appears in the word problem leads students to an incorrect answer. We are not engaging students in sense-making when we ask them to use these keywords in this decontextualized way, yet we often label these children as impulsive when they employ keyword strategies they shouldn't. More importantly, by using this sort of mnemonic approach to solve mathematical problems, we are discouraging them from reading and trying to make sense of the problem. We gear them up for this, leading them to ask, "Just tell me how to answer the problem." Instead, we want children to understand and ask, "What is the problem really asking me to do?"